Okay, here we go. Who are you? What are you doing?
I'm RJ, and I did a project on RFID systems, and I looked for a few other ways of, once I finished my basic system, I looked to expand my project a little bit, and I'll talk a little bit more about that once I get through my presentation.
What's an RFID system?
So an RFID system is basically a system which allows a receiver and or an antenna to receive a message or a piece of data, which can either tell a system to operate or not operate. In the case of my RFID system, I have a system which plays a sound as well as sends code to the computer, or a system that's hooked up to, as well as sound, computer, and light. It shows light. Okay, so I'll start with the basic system I have, just kind of getting just showing you how it works. So this is the actual RFID system. Is very it's kind of simple. It's an Arduino, a special Arduino, which has a micro USB here instead of the normal big fat USBs. I don't really know what they're called.
Okay, so in the lingo of the Arduino, you've got a shield on there?
Yes, and then I have a shield on top.
Oh, okay, gotcha.
This is an Arduino shield, and this one was obviously used so I could be able to use our RFID systems. Also, it has wireless capabilities. If I could, this is my next Hello World I created, and this one actually stores RFID tags to be read later on. So the first one verifies that the RFID tags are correct, and this piece of code actually stores the RFID tag, and this is what I could use. The XBs is the wireless that I could have used, and so I'm going to upload this one now. And so this one will basically allow a database of RFID tags to be created. So basically, if you ever want to be able to store tags that could activate the system or not activate the system, but a very limited amount of tags, then this is how you would do it. And so this one stores it on the first beep. It's supposed to store on the first beep, and then so it stores it this time, and then okay, I'll bring up serial monitor now to show. It should be showing on serial monitor.
You gotta
So
flip
there you
it
go.
back.
So the RFID tag is 3700134216.
You gotta flip it back.
Oh, sorry. Right. Yeah. So it shows up on the serial monitor every time you beep it. And so now that RFID tag is stored in there. And how it does that is it actually beeps it in the first time like normal, but then it actually checks, it rechecks to make sure the tag is the same. And once it rechecks the tag, it makes it stores that.
Okay, Ian, you're on.
Alright, so for my spring project, me and my partner, Nick Richardson, wanted to build a autonomous fridge. And what that basically would do is, it would be this nicely built fridge that would be able to tell you and send you text messages whenever a item in the fridge changes. I had a function that says main sensor get digital input. So this main sensor would tell us when the fridge is open or closed. As you can open the fridge, the values copy to last array.
Whoops. Yeah. Okay, door is open, and you can see
You can see the different readings when I put my hand over the sensors. So I'm on 2.3 right now, and it changed to 270.
Yep.
And same with all the other sensors. And I made this 2D array with the mind that, keeping in mind that I could use this to detect when a certain area on the fridge is different.
There we go. Okay, Mark, you're on.
Alright, so during the first few weeks of my project, I tried to learn something more about the Kinect and found out some cool programs, like this one. So what it does is this is pretty much a face tracking system. So
Let me get over on this side.
Yeah.
So
It can kind of detect human faces, and it can kind of record your expression on the black screen.
So bottom line, you're trying to do what was cutting edge when Leonardo could recognize Big Bird and Cookie Monster in that personal robotics lab.
Yeah.
Essentially what you've done, what you can now do with that and the software is essentially that same level of recognition once you've trained the system.
Yeah.
Yeah.
And I don't know if you have time.
Okay. All right. Thanks very much. So what is this thing?
This is an arm, a robotic arm, and on the front there's a hand that will move around.
Sorry, I'm going to zoom in.
And then on the front there, we also have a motion sensor to see if people are in front of it. And if an object's in front of it, the motor will move to show that someone's in front of it. If we move around.
Just a sec. All right. Okay.
And as it senses people, it starts.
Yeah, oh, absolutely. Okay. So, yeah, you look good. It's okay. Okay, here we go. First project.
All right, I'm Adam Lunday, and I did a project on programming in Arduino for sound stuff. You'll figure it out. I plug this blue wire in, and then it goes to this contraption right here, and this is the sound mic. So I'll show you guys what it does real quick. Pay attention to over here. These lights, yeah. You guys see them flash? Yeah.
Okay, you're on.
So for my project, I decided to create a music tuner, and so this is kind of inspired by me playing the violin, and having a music tuner helps us to make sure all your strings are in tune. And as I turn this knob, first there's two sets of LEDs. The ones up here on the top right are to determine whether or not the pitch is in tune, high, sharp, or flat. And then there's another set of LEDs attached to the breadboard that determine what the note is being played. And so this note that's currently flashing is a D, and as I turn the knob to be higher frequencies, you can see that the pitch is getting sharp, and then it'll get flat and then in tune again because it moves up the scale.
Okay, so here we go.
So,
Okay, you guys are on.
we got this pretty broken down wheelchair from an old project, and the biggest challenge actually was the hardware in the first place.
Uh-huh.
And so one side, I think it was the right side, had a working gear, and the left side did not. So we, Clarence actually figured out how to get a gear on there that would work with the band that you might be able to see right there that runs all this. So once we got that going, that took a couple weeks. The next thing was to set up the APM controller. Or we did Cortex first. Cortex was pretty simple. We set it up in the same way that you use a VEX controller. That worked pretty well, so we went to the APM. And we also ran that all down.
So wait a minute, the APM there, usually that's used to control helicopters.
And drones.
Okay.
We had 5 more weeks.
What it can do is run off of this controller pretty effectively.
And that runs through the APM control.
Okay.
Demonstrate that.
So here we go. So stand back.
So it's not the most precise system, but it is very fast.
Yeah.
Get it on the string. We never run out of.
Yeah. We went all the way up Lecture Road.
Yeah. So
My goal was to make a ideal couch for a dorm room, whether it's for school or college. So that basically required it to be lightweight, durable, strong, mobile, and not very expensive. So this is like the bottom piece.
I'm going to zoom in here.
And then, so I cut out a bunch of pieces that were the right size of that, and I cut out a bunch of vertical pieces, which are these, and I stacked them together every other, and used some scrap material of the plastic as filler to keep the strength, while trying to not use that much material.
Comfortable.
I mean, it's cardboard. I haven't put cushions on it yet, but like, it's very even, so it's not like, is it wide enough?
Yeah, it seems really small.
Yeah, no, it is. Because
It has
You're on.
I think my project was a hovercraft. I saw a video on YouTube of someone building one of these out of some really simple materials, and I mean, I think my like formal design proposal was like to use it for like fishing or something. But I mean, to be honest, I mean it's a hovercraft. Like, who doesn't want to build a hovercraft? It's really cool.
So, but putting it on water at some point?
Yeah. So I mean, I'll
Except
talk about that later.
being electrocuted. Other than that.
Basically, it's made out of, you have like a plywood base. For this one, I built a prototype first, so I used like a smaller rectangle. But you have the plywood, and then this is, you have like a hole for the leaf blower, and then there's this, which is called the skirt, which is the sort of pocket of air that it floats on. And then you have to cut holes for the air to escape. And then this is the first one I built. The plastic wasn't as durable, so it ripped a lot, which is why there's like 10 tons of duct tape on it. But this worked pretty well, but I think building this helped me a lot with building the second one, which is here. And for this one, I mean, obviously, I put a seat on it, and it works a lot better. And I had the first leaf blower on the first one, but I didn't really know how to propel it, and it's
so loud. It's so loud.
All right.
Run it. Gives you a resized window with the interior design in it, with 4 different shapes in it, each representing something. Like this would represent a bureau, this would represent like a desk, this would represent a bed, and this would represent a chair. And they're fully movable inside the area and also confined to that area, so you can't actually move them out of it. And yeah.
How hard would it be to add like a left click rotate?
I had one where I had that sort of earlier. I had you could press the left mouse button and actually shift it a little bit.
Nice.
Yeah.
Nice job, though.
Mine was, I was looking in Swing to try to create a sort of place to run everything. Which would have been this window, and hopefully, I mean, ideally, given more time, we might have been able to integrate. So this would have been a place where you can put in the dimensions of your room and feet. Right now, it's
yeah, okay.
Right now, it's not connected to any. We tried setting up action callers and action listeners to sort of hook this program and make it appear here, but we couldn't manage to do that. Also, there are 2 drop-down menus for creating rooms, adding rectangles and circles to represent various types of furniture, and also a print function if you wanted to use it as a blueprint for your own room.